Calculus kids, this is Dr. Callahan with week 17, Wednesday. How are you guys doing? Congratulations on making halfway through the week. All right, go ahead and pause the video and answer the following 3 questions for your warm-up log. All right, so let's go ahead and take a look at the remaining 4 questions for the free response of the 2021 question that was asked. So we went over question number 1, that's with a calculator. And then we also went over question number 3, which was without a calculator. And so then today we're going to go ahead and take a look at question number 6 without a calculator, because it's not a question on slope fields and differential equations. And I feel like, a lot of the questions that we've gone over, we haven't gone over a ton of these ones, although they're not exactly the most difficult ones, but it's also on separation of variables. So you're going to have using the E, the LNs, and then the C, E to the RTs, if you guys remember that from differential equations. All right, so this is the question for number 6. It says a medication is administered to a patient. The amount in milligram of the medication is in the patient at time t hours, which is modeled by y equals a of t, which satisfies this differential equation. So this is the change of the medication that's in the patient's system after so many, hours. At time t equals 0 or 0 hours, there is 0 milligrams of the medication in the patient. So a portion of the slope field for the differential equation of dy over dx is given below. And it asks you to sketch a solution to the curve through point 0, 0. Well, that is probably the easiest possible question. I mean, here is 0, 0. Okay, I probably will notate it. And if you just go with the path of where the slope field is going, this is kind of where it's going. Okay, so you know that the dy over dt is equal to 12 minus y over 3. And you know that a of 0 is going to equal to 0. And that's all you need to do. That's basically it. All right, so then let's go ahead and take a look at question B. With question B, it says, using the correct unit, interpret the statement as t approaches infinity, a of t equals 12 in the context of this problem. So here is t. As t is going to infinity, what you notice about the milligrams in the patient is that it is going to be at 12 milligrams. So you could start saying as the limit t approaches infinity, a of t is equal to 12, indicates that as the number of hours approaches infinity, and while the medication is being administered, the amount of medication in the patient is going to approach 12 milligrams. So then the amount of medication in the patient is going to approach 12 milligrams. So here's your t. As t approaches infinity, looking at this curve right here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's about approximately 12 milligrams. Another way that you can describe this is you can say as a limit t approaches infinity, you know that a of t is equal to 12. So as time approaches infinity, the amount of medication in the patient will approach 12 milligram. So you can go ahead and write this however you want using whichever verbiage is, worthwhile to you, but that is sufficient for this problem. All right, let's go ahead and take a look at C. So C is the part where you have to actually use a little bit of calculus without just interpretation with equations. It says use separation variables to find y equals a of t, and then evaluate it with the initial condition of a of 0, which is equal to 0. So let's start off with dy over dt is equal to 12 minus y over 3. Now I could go ahead and rewrite this. So I have a 1 over 3 and negative 1 over 3, y minus 12, just so I have the y kind of a positive. And then what I want to do is I want to have the y's on one side and then the x or the t's on the other side. So I'm going to separate this. So I have y's on the one side and then t's on the other side. So in order to do that, I'm going to have dy is equal to negative 1/3 y minus 12, multiply the dt over. And then I also want to get rid of the y minus 12, so I'm going to divide it by y minus 12 on both sides. So that part is gone. So now let's go ahead and integrate both sides, you guys. So integrate both sides. And what ends up happening on the left side is, remember, the integral of 1 over y minus 12 is ln y minus 12. Remember, our goal here is to solve for y equal to negative 1/3. The integral of dt is just going to be, it's 1. So integral of 1 is just t plus c. So if my goal is to get y by itself, I need to go ahead and get rid of the ln. How do I do that? You put an e on both sides. Ln e cancels, y minus 12 equals, remember we did this when I said this is a constant c, it goes in the front right here. So ce to the negative 1/3 t. Now, you still have the 12, so I don't want it there, so I'm just going to add the 12 on both sides, which is y is equal to 12 ce to the negative 1/3 t. Now, my equation is not complete because I need to figure out what c is. So what I'm going to do is I'm going to use the point that's given to me, which is at a of 0 equals 0, to find my c value. So let's go ahead and try to do that. So I have x equals 0, y equals 0. So 0 equals 12 c e, and I shouldn't say that is, it's actually t. Sorry about that. So t equals 0. So negative 1/3 times 0 is just 0. And remember, with algebra, e to the 0 power is just 1. So you have 0 equals 12c. And from here, I just realized that I made a little typo. When I move that 12 over, it's a positive 12 plus c. Sorry. There we go. So c equals negative 12. Now that I have c equals negative 12, I can go back to my original equation, which is a y right here. So I can change that y to a of t is equal to 12 plus negative 12 e to the negative 1/3 t. And this right here is going to be your equation. All right, let's take a look at part C, or I'm sorry, part D, which I'm not quite sure what happened here because I don't see D over here. Oh no, I think I accidentally cut it off. So I'm sorry. Hold on a second. I'm so sorry. I just realized that I completely cut off this part D, which was on a separate piece of paper. So you won't have that, which is part D, on your guided notes. I'm so sorry about that, but you do have it here. So take a look at part D. I guarantee you that will not happen on your AP exam. So part D basically says A different procedure is usage administered medication to a second patient. The amount in milligrams of the medication of the second patient at time t is modeled by that function y equals b of t that satisfies the differential equation, which is the rate of change of the milligrams of medication given to the second patient. At t equals 1 hour, there are 2.5 milligrams of medication in the second patient. It is the rate of change of the amount of medication in the second patient increasing or decreasing at t equals 1. Give your reason, so you're going to have to justify it with words in the situation for this question. All right, so at t equals 1 hour, there are 2.5 milligrams. And so you know that your rate of change is going to be dy over dt, which is 3 minus y over t plus 2. And so this is the first rate of change, dy over dt. And because they want to ask you if it is going to be increasing or decreasing, well, you will have to find the second derivative to figure that part out. So I will have to go ahead and find d squared y over dt squared. So looking at this problem here, as you're looking for the derivative of this, derivative 3 is obviously going to become a 0, so I don't need to worry about that. But then here, I'm going to have to do the quotient rule because your f is going to be y and your g is going to be t plus 2. So this is in terms of y. So anything that has a derivative of y, you have to put a dy over dt. So f prime is going to be 1 dy over dt. G prime is just going to be 1, and then g squared is t plus 2 squared. Now, remember your quotient rule is going to be f prime times g minus f times g prime over g squared. So then looking at this here, you have a minus, which is kind of pesky, but we're going to go ahead and put it on the outside. So I'm going to do f prime times g, so that's dy over dt times t plus 2 minus f times g prime, so that's just y, all the way over t plus 2 squared. So they also give you, if we want to go ahead and solve this a little bit more and make it look a little bit better, it also gives you that at t equals 1 hour, so when t equals 1, you know that your y value is going to be 2.5 milligrams. So let's go ahead and maybe use that information to plug it in. Okay, so then looking at this here, we have t plus 2. So that's going to be 1 plus 2 because your t is 1. So that part is going to be a 3. And I'm going to try to change this to a different color so that way we can keep track of what we're doing. So that's going to be a 3 minus y, which is a 2.5. Denominator, you're going to have 1 plus 2, which is a 3 squared, which is a 9. All right, so then I have this pesky dy over dt, but lucky for you, if you look in your original equation, it's given to you that the equation for dy over dt is going to be 3 minus y, which is 1. I'm sorry, 2.5, sorry, over 1 plus 2, which is 3. Okay. So then here, what you're going to have to do is, this is a without calculator portion of the task, so you would have to go ahead and find a common denominator. If I make this into a 3, this will become a 9. 9 minus 2.5 is going to give me a 6.5 over 3. So then looking at this part here, I'm going to have a 6.5 over 3 times by 3 minus 2.5 over 9. And the entire thing here is negative. Now this 3 and this 3 cancel, so I have 6.5. 6.5 minus 2.5 is going to give me a 4 over 9. And so that's just be a negative 4 over 9. Well, the second derivative is a negative 4 over 9, which is less than 0. So what that indicates to me is that because it's less than 0, the medication rate is decreasing. So because it asks you to give a reason, what you can say is, given that d squared y over dt squared is equal to -4/9, which is less than 0, therefore, the rate of change of medication in the patient is decreasing at t equals 1 hour. And that is sufficient for this question. All right, you guys, well, that's all I have for you today. So if you're done with this question, what I would recommend you doing is make sure you review the other 3 questions, such as question number 2, question number 4, and then question number 5. As always, I hope you guys have a wonderful week, and I'll see you guys next time. Take care.